We're going to be going over how to do hand assembly for the tracing chart that we've previously looked at. Now, in the video, we did this kind of tracing chart, but we're going to be doing the hand assembly for this one up here. And we would just run this in our debug menu using these values that we input right here. And these values we've done before, that's in blue. And that is in the playlist link below the like button. So we have this part right here. If we unassemble it, we're going to get this right here. And so we're going to want to match this with our hand assembly inside of here. We could also use this tracing chart because we have all of the different parts here and what it's supposed to update and look like. So looking at this, we'll look at this, and I'll keep the tracing chart up here just for reference because there's already so much spreadsheet on the screen. But looking at this one, we have our titles, and then we're first going to have our instruction. We're going to have our address, and then we're going to have our operation, our destination, and source all on the same line. And then we have our instruction format. We have 2 binary, and then we have the 2 hex. So we can see the first operation, and when we look at these, we're going to be looking at the instructions, which is why it's important to actually look at this right here. So we see our first instruction is going to be move dx to 100 or 120. So we have move dx 120. That is our instruction. Our address we're starting at is going to be this IP. So we're starting at the instruction pointer. It's going to be this 100 here. Our operation, we have it to be a move. We have our destination to be dx, and then our source is 120. So our source is 120. We're moving it to the destination dx. What kind is this? Well, we're going to have to look at this as well. And this is a pretty big document of things that we're going to have to look at. So with this one, we know it's a move. So in our document for the hand assembly instruction handout, we can scroll all the way down until we get to this part right here. And we're going to find the move. We have found move. And with our move, we know that our 120 is a constant, or it's an immediate. We know that dx is a register. So what we're going to do is we are going to move this constant into our register, the immediate to the register. Now this is a special type right here, this d of x. So we are going to look in our move. This is our type. We are going to look, we can see immediate to register. We have it right here. We're going to be using alternate coding. And that's just how it is going to be for this lab unless it's otherwise specified, because it reduces our data size. So we have alternate coding that we're going to be using. That means we're going to have 1, 0, 1, 1, and we have our WREG, immediate data. So we have 1, 0, 1, 1, WREG, and then our immediate data. Now let's continue. So we're going to write, we have to write all of this out. We need to translate this into binary because that's how our x86 instructions work. So the first part is going to go down here. We have our 1011, that is going to be the bits that we have here. Now we need the next part. So we know that we have a W, and we know that we're moving into register DX. So pretend W is not even there. How would we find W? Well, we would scroll up here, and we would come to this encoding of reg field when W field is present in instructions. So if we have a D of X, we can see that we are going to be in a column right here. So that means our W is equal to 1 because we're using the 16-bit. So that means W is equal to 1 here. And now let's look at our REG. So still at W is equal to 1, we're going to look across and our register is 0, 1, 0. So our register is 0, 1, 0. So we have 1, 0, 1, 0. That means we are going to combine this 1 and the 0, 1, 0 together right here. Whenever we have something like this, we're going to want to combine the bits to make 4 right here. And so when we combine them, we have 1, 0, 1, 0. And if we use the Windows calculator, we can see that a 1, 0, 1, 0 is just going to be 10 or A in hex. So we will write this out in hex right here. And this is going to give us a 10. Now for the next one, because, oh, by the way, it's because we have 2 to the 0th, so that's 0. We don't use that. We have 2 to the first, we use that. We have 2 to the second, we don't use that. And then we have 2 to the third. So we have 8 plus 2, it's going to give us the 10 here. That's just binary to convert the conversion from binary to decimal or to hex. And then next we have the immediate. And for the immediate, it's going to be slightly different. What we're going to do is, because we use little endian, we are going to take our instruction right here, the source, because we've dealt with the register, right? Now we're going to look at the source because we have to touch everything. and we're going to take this value and we're going to place it here. However, we can't just write in 0, 1, 2, 0. We have to do the upper bits first, or I'm sorry, the lower bits first. So 2, 0 are the lower bits, and they're going to need to be written first. That's why we have the 2, 0 right here. And then after our 2, 0, the two lower bits, we have our 0, 1. And so we have 2, 0, 0, 1, and this is in hex, so we press the H there. And so in binary, we're going to have our 2, 0, 0, 1, and that's going to come down to be 2, 0, 0, 1. And so our hex is BA 2001. And that's how we would do this first one.